Hi girls, we're going to prove those theorems. We're proving theorems 3, 4, 5, 6, 7, I hope. So we're going to start with circle theorem number 3, which is, so theorem number 3, what was that, girls?
The angle at the centre of a circle is twice the angle at the circumference subtended.
So the angle at the centre is twice the angle at the circumference subtended by the same arc. Circumference subtended by the same arc. It is circle geometry, so we know it's the centre of the circle. Okay, the way that we prove this, it is actually also in your textbook, girls. So I'm going to draw here that I've got the angle at the centre, and here is my angle at the circumference there. Now with this proof, we need to draw a line through, I'm going to call this A, B, C, and I'm going to put this as O for the centre. I'll try and put it there. Okay, now to do this proof, we draw a line. Actually, I'm going to change those values, and sorry, I'm going to call that A, just to make it the same as your book, A, B, C. That way it's the same as your book, so if you're following from there, it won't be too bad. So we're going to draw a line from A through to the centre O, and a little bit further down to D. I'm going to put D outside the circle. Okay? So, the first bit is to join AO. So join AO and produce to D. And then we're going to let angle BAO equal X. So angle BAO equal X. And we're also going to let angle CAO equal Y. And let angle CAO equal Y. Equal Y. Okay. Therefore, we can say that angle BAC, which is made up of those two angles, is equal to X plus Y. We also know that because OA is a radius of the circle and so is OB, that OA, the length OA equals OB. So I'm moving over here, and we know that OA equals OB because they are equal radii of the circle. So therefore, we've just said that angle BAO is X. Therefore, we can also now say that angle OBA is equal to angle BAO, which equals X. Reason? Base angles of isosceles triangle. Okay, because it's an isosceles triangle, these two base angles will be equal. Base angles of isosceles triangle. Now we can also do the same in triangle OAC. So we know also that OA is equal to OC because they are also equal radii. And so therefore we've got that angle OAC is equal to angle OCA, is that right? Yes, which equals Y. Again, base angles of isosceles triangle. Okay? You can actually say which triangle we're talking about. So in the first one, it was base angles of isosceles triangle AOB. And in the second one, it's base angles of isosceles triangle AOC. Okay? So now that we know that, girls, our aim is to work out this middle angle in there. And if this angle at the circumference is X plus Y, what do you think we need to show that this angle in the centre is going to be? Double that, which is 2X plus 2Y. So that's what we're trying to prove. That this angle in the centre, we're trying to prove that angle BOY is double the X plus Y. Now double X plus Y is 2 times bracket X plus Y, or 2X plus 2Y. That's what we're trying to prove. Now, girls, if we just look at this triangle BAO, we know these two angles. I could work out the exterior angle of the triangle and work out this little blue section here. So this little blue section there is what?
2x.
It's 2x because it's the exterior angle of triangle BAO. So we've got that angle BOD equals angle OBA plus, oh actually I might just write x plus x because we can see that. So angle BOD is equal to x plus x, which is 2x, and the reason is it is the exterior angle of triangle BAO equals sum of interior opposite angles. Okay? Similarly, we can say that angle COD is equal to what? What do you think it's equal to? That's the exterior angle. So that one's y plus y. So angle COD is y plus y because the exterior angle of triangle COA equals sum of interior opposite angles. Okay? So y plus y is equal to 2y. Therefore, we can say that angle BOC is equal to 2x plus 2y because it's the sum of BOD and COD. And we can take out 2 as a common factor, which is 2 lots of x plus y, which happens to be 2 lots of angle. Now we know that angle BAC is x plus y, so it's 2 lots of angle BAC. Okay, and that's the proof. Therefore, angle BOC, we can see down here, is equal to 2 times angle BAC. So therefore, we've just proved that the angle at the centre is twice the angle at the circumference subtended by the same arc. Okay? That's circle theorem number 3. Sorry, girls. Can someone... I just stuck my face right in here. Right. Sorry, girls. Not a pretty sight. Right. Can we... I'm trying to... Getting all these... Okay. Good. Girls, I'm going to do circle theorem number 4. I'm going to move the table over here. I'm hoping you can see all this. So we're going to start circle theorem number 4. Now I can't pause the video because it'll stop. So, all right, that looks okay. You all ready, girls? Okay, remember circle theorem number 4 is sort of derived from this, that if that angle at the centre is 180, then the angle at the circumference will be 90. So circle theorem number 4 is that the, anyone know? Angle in a semicircle. Now this is a really easy proof. Alright, circle theorem number 4. Angle in a semicircle is a right angle. Okay. Yes, you can. So girls, okay. I'm going to put the same letters as what's in your textbook. So we've got A, there's my centre of my circle O, and I've got B, and I've got C. Now see girls, if you're trying to prove that angle in a semicircle is a right angle, you're allowed to use any other theorem that you know to do it, okay, apart from that theorem, okay? So I'm going to say let I'm going to go, all right, well we know that angle AOB, well we've got, wait a sec, we'll start again. AB is a diameter of the circle. Therefore, angle AOB has to equal how many degrees? 180 degrees. Equals 180 degrees because it's a straight line. Okay? Therefore, angle ACB equals 180 divided by 2, which is 90 degrees. And the reason for this is that the angle at the centre is twice the angle at the circumference. Therefore, our theorem's proved. Therefore, the angle in a semicircle is a right angle. Girls, I can't pause the video. Okay, we're going to move over to angles in the same segment. Girls, you should be away a bit more often. Everyone's so quiet in this classroom. Okay. Okay. Everyone done circle theorem 3? You haven't finished writing it? Okay, see, Gloria. That's Gloria holding us up. It's all right, they'll feel like they're here. We'll get everyone to come and say hi at the end. Okay? All right. Okay. So, circle theorem number 5. I think we're going to do... Remember, circle theorem number 5 is sort of broken up into 2 parts. The first one I'm going to do is angles in the same segment are equal. So, what we're going to do, just by drawing the diagram, we're going to try and write up the alternative wording. So, oopsie. So, okay, girls, we've got angle A, point A, point B, point C, and point D. What we are trying to prove, that angle ABD is equal to angle ACB. So we are trying to prove that angle ABC is equal to angle ACD. That's what we're trying to prove. Okay, now the alternative wording for this theorem is that angles subtended by the same arc are equal. Okay? See, these 2 angles are sitting on the same arc. Instead of saying sitting on the same arc, we say angles subtended by the same arc are equal. So girls, what you do, you'll know your diagram. You've got to try and describe the diagram. That's how you remember your theorems. So girls, we've got to prove that angle not ABC, it's ABD. Thank you. Prove that angle ABD is equal to angle ACD. Okay, girls, in this proof, we have to put in the centre O. So what we're first going to do is that we're going to join AO and DO. Remember, O is the centre of the circle. So we're joining those. And by joining those, I think we're going to utilise angle at the centre is twice angle at the circumference theorem. See, girls, circle theorem 5 is just angles in the same segment are equal. Circle theorem 3, remember, was angle at the centre is twice angle at the circumference. So if we let, say, this angle up here be something, we know that the angle at the centre is doubled, therefore this angle at the centre is half, so those 2 up there will be equal. That's our rationale for this proof. Okay. Now I'm going to do it slightly different to the book. Let's just say let angle ABD equal theta. So therefore angle, what do I say now? If ABD is theta, therefore angle AOD is 2 theta. AOD equals 2 theta. Reason, angle. Now girls, in geometry you're allowed to use abbreviation for a couple of symbols only, and that's angle equals triangle. No, op vert, nothing like that. Okay? So angle at the centre is twice. Yep. Angle, you don't have to put the and all those. Angle at centre is twice angle at circumference. Standing on the same arc is a good idea. You can say here, angle at centre is twice angle at circumference. Yeah, standing on arc, on the arc AD. Can you see they're both standing on arc AD? That angle ABD and angle AOD both stand on arc AD. Okay? Now, from there we can now say, so I'm going to actually move that O up here. So if that's theta, this is 2 theta. And now we can say, well, if this middle angle here at the centre, if the angle at the centre is 2 theta, then this other angle at the circumference is also half of that, which is theta. So angle ACD equals a half of angle AOD, which equals a half of 2 theta, which equals theta as well. Reason, again, angle at centre is twice angle at circumference. I'm not going to put standing on the same arc. Got it? Therefore, angle ABD is equal to angle ACD, which equals theta. And that's the proof for circle theorem number 5. Okay. Do you want to cut, do you, girls?
We have an exam next week.
Oh, okay. Oh, yeah, and it's only 2 minutes to go. Okay, girls, everyone's writing. No one can come and say hi. So what I want you to do, girls...
Hi.
All right, everyone's saying hi. So what you do is you look through the videos and the GeoGebra videos and copy these proofs. I have not set any exercises for tonight. Just keep revising. I'll start next lesson with circle theorem 6 and... Did we do... Oh, yeah, we'll do the next part later or whatever. Bye, girls. Someone stop this for me, please. And then put it to YouTube. That's Katrina. She's saying hi.